Welcome. Jeremy and I will be talking about Sinopia Linked Data Editor and the Questioning Authority Lookup Service. We'll primarily be talking about the lessons we've learned over the past year and a look ahead to where we're going next. I want to give a quick system architecture overview to orient you to the system. Sinopia is a cloud-based linked data environment with a React bibliographic editor based on user-defined resource templates. It stores RDF in a back-end Trellis data store. Sinopia makes requests to the Questioning Authority Lookup Service, which ultimately gets the data from either our cache of authority data or directly from the authority provider. The process looks like this. Sinopia makes a request to QA. The URL has the same basic structure for all authorities. QA translates that URL request to one that's specific to the cache or the external authority. The structure of the authority URL is configured in QA as an IRI template. This effectively hides the details of each authority, making the request process for the application simpler and more consistent. Similarly, each authority returns data in various linked data ontologies and encoding formats. So QA again is configured to understand the results that are coming back from the authority. This enables the final step where QA normalizes the results into a consistent structure that the end user application can use to display search results to users. This allows the processing in the application to be the same for all authorities. Let's take a look at some of the lessons we've learned about the lookup service and the cache system over the last year. Going back a little further, since January 2018, we've been steadily adding authorities to our caching system and increasing configurations for direct access to authorities. One barrier to direct access is that few authorities provide search results as linked data, which is required for quick configuration-based access in the QA normalization layer. This is a list of the current set of authorities that we provide access to through the QA lookup service. Most are driven through our caching system, with some available for direct access. Additionally, we've put in the extra time required to make a few accessible outside the linked data configuration process. I'd like to talk a little about our observations of the trade-offs between caching and direct access of authorities. The primary benefit of caching is that it provides us with more control. More control over when the service is available and the ability to fix any issues that arise and get it back up and running. None of the authorities we work with provide ranking of their returned search results, and graphs created from the linked data do not by nature have any order. In our caching system, we inject a predicate to hold the rank for each result. This allows the search results to be presented with the most likely result higher on the list. The results include contextual information that helps with disambiguation and increases confidence in selections. We include pagination information that allows for requesting the next set of data if the desired result is not found in the initial set. The cache also allows us to have a consistent set of configurations that use the same parameters across all authorities. Caching does come with some costs. Most notably, it requires expertise and scalability issues around loading, updating, and indexing large triple stores. It requires significant hardware to hold the data. We are currently caching over 65 billion triples. Additionally, processing of this data and new incoming data is time-intensive. There are many complexities around how to update the cache using change management with varying degrees of support from the authority providers. In an attempt to make the processing less cumbersome, we have, for the most part, applied a one-size-fits-all approach, which doesn't always provide results based on some of the nuances of the data. Looking at the direct access side, the provider brings significant expertise to the table about their data. Their indexing approach will often take into account aspects of the data that we either do not fully understand or are not able to take advantage of. Also, it is common for there to be delays between the time the provider updates the data in their own system and when it is available as a download that allows us to update our cache system. Direct access is not without costs. At this time, the authorities we work with often provide a minimal set of data that does not include enough information for the end user to disambiguate results. The results come in a wide variety of formats. As long as the formats are linked data, the QA Lookup Service can normalize the results. But more authorities than not, at this point at least, do not provide results as linked data. And a general lack of control with direct access leans us toward our caching system. There are two areas of the caching system that we've been working on and continue to work on that directly impact the user experience: performance and accuracy. I'm going to talk a bit about what we've seen and how we evaluate these aspects of the cache. We've identified size of the data set, the complexity of the extended data, and the fact that multiple Sparkle queries were being used to construct the full result at request time as having a negative impact on performance. To set the stage, the structure of the cache is that it holds the triples in a Jinna-Fuseki triple store, and it has a leucine index over the top that is used to locate applicable entities during a search. The search process is initiated by a request from the QA normalization lookup service. The cache system searches the leucine index. The system then makes an additional search of the triple store using Sparkle to look for an exact match to the search query and marking that as rank number 1. From the list of the URIs gathered as a result of the leucine search, a second Sparkle query is submitted to get basic and extended context from the triple store. A linked data graph is constructed from the leucine search results and the results of the context Sparkle query. A rank predicate is injected for each result based on the leucine ranking. Using this process and looking at performance characteristics of the Library of Congress demographics data, we see an average response time of 2.5 seconds per request. We identified the Sparkle queries as the likely bottleneck for the process. So instead of making a Sparkle query to get the extended context at request time, which can be quite complex for some authorities, we pre-populate the leucine index with the extended context in a payload field holding the entire result graph for the entity. This greatly simplifies the request process. At this point, there's still the Sparkle query to get the exact match, but it is a fairly simple query. The results are that we lowered the 2.5 second average to just under 1 second. And by moving the exact match processing from Sparkle to leucine, the time drops to around half a second. This is currently deployed on our test server for LC demographics, genres, and performance. We'll really see how effective this approach is when LC names and share VDE complete their reindexing process, as they are much larger and more complex. We've seen common categories of issues with accuracy. As mentioned during the discussion on performance, we put in place code to ensure an exact match is always ranked first. We want to process queries using case insensitivity, such that social workers, typed in as all lowercase, matches the actual label of social workers with a capital S. We also want to apply stimming rules to allow biologist without an S to match the actual label of biologists. Stimming is a little complex for some authorities, so we're exploring the ability to have it turned on for some and off for others. The other challenge we wanted to address is to allow queries where the results are expected to include diacritics to be typed without the diacritics. To address accuracy, we put in place a testing harness in the QA Lookup Service that allows our local experts to express their expectations. They define the query, the URI that should match, the max position where the URI should appear, and how many results they want to include in the test. A test passes if the actual position is less than or equal to the expected position. It's considered marginal if the URI is in the search result set but not found by the expected position. And it is considered a failure if an error occurs or the URI is not found at all. Given a broad range of accuracy test definitions, we can analyze how well an authority or an indexing algorithm is performing. We recently used this approach as we were evaluating algorithms to support the diacritics. We used it to determine if the new approach of indexing is an improvement or a regression. So this example shows the results of 2 indexing runs. On the left, we have our current production indexing as a pretest. On the right, we have a post-test for the proposed indexing change. In this set of runs, we can see that there are many new failures and only one marginal improvement, so we actually rejected this algorithm as not acceptable. Trying a second approach, again with the pretest on the left and the post-test on the right, we see there's one test that's a little worse, but the diacritics, which we're focused on with this indexing change, are now passing. The one exception is one that starts with the glottal stop, but this represents a different class of indexing issues, so it's not a concern in this particular evaluation. The bottom line is that this new indexing algorithm is acceptable and we'll be deploying it soon. Now for a look ahead to where we're going next. We have two primary goals for the near future. One is around community collaboration and promoting approaches that work effectively with linked data environments. For this, we're leading a working group that is exploring best practices for providing a search API for authoritative data. And we are collaborating with OCLC's Entity Backbone and Entity Management Advisory Group. The other primary goal is to work toward hardening the caching infrastructure for long-term sustainability. This includes continued improvements for accuracy and performance, adding connections to additional authorities, and moving to a containerized architecture that will ease our maintenance process and make it easier for other institutions to stand up caches of their own. I want to say a little bit more about the Search API Best Practices Working Group. A strong tenet of the group is that it brings together authority providers, authority consumers, and application developers that bridge the gap between these two groups. Having all these voices at the table will improve the output of the group and increase the likelihood that we will produce a strong set of recommendations. The group is in the early stages. Thus far, we have looked at existing APIs for various authorities, defined the primary use cases of interest, and are in the process of expanding those use cases into user stories from the perspective of each of the partner roles of provider, consumer, and developer. And I'm looking forward to continuing our work toward a vision of a common API approach. I've included a link to the project wiki if you would like to get more information or follow our work.
Sinopia Linked Data Editor Lessons Learned. Sinopia Lookup User Interface to QA. When the Sinopia's Linked Data Editor first implemented a QA lookup, it was done with an input control for a type-ahead search. Users are presented with a drop-down list that matches their query and then displays the results per authority. If there's any additional context from the authority that's in the results, we also display that if it is available. So now I'm going to show you an example from Sinopia of using questioning authority. First, I'm going to select the monograph work unnested resource template. And within this template, I'm going to first show the geographic coverage of the content. So in here, in this example, we have two QA sources, the GeoNames area and place, as well as the Library of Congress's geographic names authority. So now I'm going to enter Palo Alto, and as it's searching, it's going to display the top 8 results per authority. So here for GeoNames, you can see there's Palo Alto was matched a number of times, each with more extended context that I could then select to create a triple. And you can also see the same for top 8 for the Library of Congresses. So if I go ahead and select, you can see then now I have asserted a relationship, and if I looked at the RDF, you would see this connection to the QA source. A couple of problems. The first is that if when I'm doing a search of what I'm looking for is in the results that go past the first 8, I have no way as a cataloger to query or page to find those additional sources that's past the first 8. Another problem in this particular input user interface is that if I needed to enter in a diacritic, it is more difficult, and I would have to know, for example, what specific key commands to enter in a character. Now we do have within Sinopia, for just the general text editor, we have a widget that will allow catalogers to point and find a particular resource. So if I look here, I can use this instead of having to memorize all the different key commands. Now in the next Sinopia work cycle, we plan to add in this functionality to the lookup to allow our catalogers to search using these diacritics. Sinopia Search User Interface to QA. In Sinopia's linked data editor, catalogers can use a dedicated search tab to search for resources within selected QA authorities, including Discogs and ShareVDE. Users can copy a found resource in the result sets into the editor in order to seed the creation of a new resource. Also available in the Search tab is the ability, if there's a large number of results, to page through the results to find the exact hit that a cataloger wishes to use. Finally, within the search interface, we also display in Sinopia the RDF classes and context if available. So now I'm going to show a couple of examples within the editor itself. So here I'm on the search tab. If I click on the drop-down list, you can see there's the Discogs as well as the ShareVDE individual cohort collections that are available to search on. I'm going to first select the Discogs master, and I'm going to enter in a search result query. And you'll notice what comes back is a label, the ID, in this case a URI, the class, RDF class that resource is, and the extended context. And you'll notice here we have, what's nice with Discogs, actual album art, the year, record labels, and other formats. If I scroll down to the bottom, you can also see that I can page through the large number of results that come back for this, and then I can actually use a resource that might be available. Now I'm going to show an example of doing a QA search using the ShareVDE authority for Stanford. Here I'm going to enter in the Palo Alto search query and search on it. And again, we have what comes back, the label, the ShareVDE URI, the RDF classes, in this case, the BibFrame hub and work, and also some limited context information. Now, to show you some of the differences between the native Sinopia search and ShareVDE, I'm just going to do a wildcard search, which is not available in QA. And so if I do a search here, you notice we have a couple additional functionality. I can filter by the class, I can filter by the institution, and I also have the ability to sort my results depending on what I'm looking for. So these are some of the differences that we are going to look to help improve the QA search interface within Sinopia. Sinopia Linked Data Editor, a look ahead. The first thing we're looking ahead to do is improving the RDF authority import into Sinopia. We saw before in the search user interface that there are different features for finding a QA resource for importing into Sinopia. However, importing RDF into Sinopia from a QA ShareVDE authority source is not always successful. We are looking at creating better alignment between the ShareVDE RDF and the internally with Sinopia's resource templates. We're also looking at a possible replacement for the manual selection of resource templates in that importing process with machine learning. Finally, to improve the RDF authority import, we may look at adding more QA search sources that are available for search. So I'm going to show you what we're talking about within Sinopia. So here within Sinopia, if I go and do another search and bring up the search results, now over on the right here, there's this copy button. And even though we have the classes, when I click on the copy button, the cataloger has to manually choose a resource template to use. So if I select a monograph work resource template and hit save, that's going to import it into the editor. And you'll notice, and this is part of the problem that we're looking at solving as we look ahead, is that we have a number of triples that didn't import successfully based on how it's mapped with the resource template. So it's this sort of disconnect between the source or the external RDF and internally with Sinopia that we're looking to solve in a couple of different ways. Also, the actual selection process where you saw the pop-up modal, we plan to replace that with a machine learning approach. Looking ahead, there are a couple of other changes to Sinopia to better support questioning authority. The first is in our user interface, where currently, as we shown earlier in this presentation, catalogers, when they're using QA within the editor itself, are limited in the drop-down selection list in that we only display the top 8 results. And it's also hard to see the extended context within that drop-down list. So in the next Sinopia work cycle, we will be replacing that drop-down list with a pop-up modal. Here in the slide, there's a link to this issue. And in this issue, there's a couple of mock-ups of what this new modal may look like. And in that new modal, you'll see here that there's the search term. There's in more of a tabular format, the different attributes that are coming back from the QA result set. And this will make it easier for the cataloger to select a resource that best meets their need in their particular cataloging context. Another advantage of this pop-up modal is that we'll be able to display and allow the cataloger to expand beyond the top 8 results. So both these changes in the user interface and in the results paging will provide better functionality for the actual cataloger use of Sinopia. Looking ahead, we'll also look at expanding support for other authority sources. Myself and another developer on the Sinopia team are part of Lynette's working group on linked data API best practices for authorities. Our intention is that using the work of this working group, we will provide support for those institutions that wish to use a local authority source, as long as that authority source conforms to this new API. And this will allow institutions that have a authority or source of data that may not have any interest outside of their particular institution to use it within Sinopia.
We would like to acknowledge the work of our colleagues who have been major contributors in moving this project forward, and to thank the Andrew W. Mellon Foundation for their generous funding of this work. In closing, we provide links to places where you can learn more about Sinopia and the QA Lookup Service.